Good day, sir. I am Midshipman Pareño, together with Midshipman Padrigao, Midshipman Plantinos, Midshipman Pueyo, and Midshipman Piñas, and we are Group 6. And now, we're going to report about the optimizing book cargo handling efficiency through advanced technology and intelligent logistic solutions. So, first, consumers of transport services increase the requirements for the condition of transport service, quantitative and temporal parameters, which necessitates the improvement of the system of organization of ship traffic flows, along with enhancing the technical equipment. The major challenge of transport is to improve the use of the rolling stock. Increasing the efficiency of material flow management are undoubtedly of practical interest to the country's economy. So their application will enable the enterprises to effectively operate both on the domestic and foreign markets. So most of the attention is paid to the application of logistic approach in selecting rational parameters of the distribution channels of cargo flows. So in terms of stable traffic flows between senders and recipients for the system of organizing railroad ship flows, the most effective is the application of the logistic approach when delivering bulk cargo, like iron, ore, coal, oil products, and etc. Literature review to reduce the expenses necessary for traffic flow processing optimization of technological parameters of the process of functioning of production and transport complexes is required. This allow a transport policy taking into account the interest of cargo's owners and ultimately increasing the traffic as well as improving the economic position of the railways. In the condition of the transport market cargo, delivery by the cargo owners is based on the criteria for assessing the quality of railway transport operation just in time and with minimal cost. Of great importance is the release of production stocks of raw materials when delivering goods just in time with optimal lots. So as you can see in the picture, there's an icon that's surrounded of the cargo ship. So that's the advantage. They can all mariners can see all the details and the things that can happen in the future. Almost 80% of all ore, 76% of all cargo, 66% of flask, and 58% of coal, and 43% of chemical and mineral fertilizers are transported on the routes. So the advantage of cargo transportation by routes consists in the fact that the cars on the given routes follow from the loading station to the destination once without being processed at the puzzling technical stations. As a result of which the turnover time of the car is reduced, the delivery of goods is accelerated. The cost of transportation drops and the volume of work at sorting and divisional stations decreases.
To minimize the cost of resources and fulfill the principle delivering goods just in time, it is necessary to organize a technological process that involves the interaction of production, transport, and consumption, technological harmonization of the work of the manufacturer's transport sector and production consumer results in obtaining a synergistic effect. The technical and technological structure of the PTC depends on many factors: the form of material and the technical supply, the range of manufactured products, the type of trunk transport, the methods for organizing transportation, technological routes, wagon lots, the features of the production technology, and etc. It has been established that at present forms and methods of interaction between production and transport appear to be ineffective, and the management of the material flow process is based on unilateral and unjustified expenditures of transport resources. To solve the problem in question, a new approach based on the development of optimization models for production transport system subsystem operation is needed. The generalizing parameter of transport logistic process is efficiency. There are many approaches and techniques to assessing the effectiveness of production and transport processes. It remains difficult to make an economic assessment of various activities, selected services, or transport operations. The research shows that the analysis of technical and operational parameters of transport and transportation processes helps to identify the reserve for increasing the efficiency of transport performance purpose. The purpose of the study is to increase the efficiency of the process of bulk cargo delivery by exit routes by optimizing the technological parameters of the supply chain. Research objectives are to carry out modeling of the production and transportation chain operation. For bulk cargoes, delivery by the example of iron or raw material by technological route and analyze the result obtained to develop practical recommendation on the formation of technological process of joint work of the subject and the entire production and transport chain operation or PTC to develop a methodology for assessing the economic effect of the bulk cargo delivery process, coal, or etc. by exit routes methods.
In most cases, the car of the network fits are fed to the quarries or mines by routines and returned back in the same manner. Empty trains arrive for loading are usually taken to the assembly control station to be further divided into separate groups of car which are then fed to the loading areas. As a result of the uneven approach of empty cars both on separate days and during these days, conflicts arise in this condition. It is necessary to create a fixed rate of gondola cars stock as their technical and commercial failures is possible. As a result of earlier studies on example of iron or raw materials delivery, a target function was formed which is the specific cost associated with the operation of the entire PTC, the cost of the supplier and execute the order, the cost of final finished product storage at the shipper's distribution center, costs associated with transportation by the main transport, the cost of storing goods and consignees location. Unmanaged parameters are as follows: duration of the metallurgical enterprise, produced cycle QN due to the technical equipment of the loading and unloading points, the ship's freight tal, and the car hire charge SIR. The optimized parameter are following: the exit route train, the performance of the loading areas load, the The delivery interval in the specific cost per one car mean for optimized parameters of the range of the change was analyzed. The productive of our mines institutes up to 20 ton per day, and for small one, for medium 1 to 700 tons per day, and the large up to 500 tons per day and more. On this basis, a range of change in a performance of the loading point load 600 was the set given the current load. The maximum number of cars included into the train is due to the length of the receiving and dispatch track as well as the train mass limitation. Depending on the types of locomotive, the profile of the road, the type of the rolling stock, loading capacity, the speed of movement under the estimated lift, and as a rule, it does not exceed 60 cars. Therefore, was assumed the simulation was carried out for the set value of the mathematical model uncontrolled parameter. On the basis of the simulation result, obtained graphs of the dependence of the total cost of the parameter of the traffic channel freight flow. Figs 1-2. According to the which of the tendency of the investigated function behavior is analyzed, our contract in the simulation result show that with the increase in the performance of the loading point, a loading up to the value of 324.21 R, the cost of per car is reduced to reach 1,280.7. The composition of the route begin followed in the case in optical and equal 38 cars, and the delivery interval of 1.75 days, further 175 days further with the increase in the parameter load, an increase in the total cost of R is observed.
This is due to the fact that with the increase in the performance of the loading point, an additional cost for the maintenance of loading and unloading mechanism arises. These costs exceed the saving achieved by reducing the downtime of the cars under loading. Figure 1 shows the dependence of the specific cost per car on the number of cars in the technological route, which make it possible to determine the technological route optimal composition at different loading point performance. Loading point can be established with the dependence obtained for the contractual value of the transport dispatch composition of the technological route. So at M equals 22, WAG equals 187, T, H, R equals 1303.6 cu at WT. Thus, as a result of modeling the operation of the production and transport chain for the delivery of all cargoes by exit routes, the size of the cargo batch mean various specified condition is determined. Having obtained the optimal values of unit cost for each group of indicators allowed MN, it is possible to consider the measures requiring improvements in technical equipment and rationalization of technologies that facilitate their achievement in general as a result of modeling the process of function of the production transport chain of all cargoes supplied by exit routes. The rational values of technological parameters were obtained the size of the consignment and the performance of the loading point, unload, and delivery interval n. The efficiency of the production and transport chain operation for delivery of bulk cargoes by exit routes is specified by the following indicators: the intensity of delivery of goods, the implement of the agreed delivery time, the duration of the order service cycle, the size of consignment, the level of capacity utilization, preserving the quality of the cargo upon delivery. As a result of the rational technological parameters obtained, the potential effect for the owner of both cargo and cars is estimated. The formalization of separate components of the economic effect is proposed.
Realize the basic requirement when delivering product to the consignee, delivery of goods just in time, and achieve a high efficiency the system's operation, a technological process of joint work of subject of the production and transport system based on the coordination of production, transport, and consumption should be developed and implemented. Production cycle of vendor is interchangeable with a number of chips depending on the number of uncontrolled parameters. The density of transport and materials flows, the performance of loading and unloading machine and distribution system, etc. Shipment of raw materials is carried out a deterministic mode, which is primarily due to the technology of minimal extraction and the dressing complex operation, as well as the specific of cargo itself. In turn, the production cycle of the enterprise user is oriented to the round-the-clock operation mode. Moreover, the intensity of raw material supply for production should correspond to the optimal or supply mapped. The process of raw material supply, coal, ores, etc. to the consignee involves several stages. Finished products are stored at the manufacturer's location at the time of shipment being the first stage. As the second stage of cargo transportation, operation of vehicles, loading are carried out. The third and main stage is the transportation process itself. Then the product is unloaded, delivered to consumer's warehouse. The fifth stage, where it is also stored in the form of stock to the time of consumption. The fifth stage, using the optimal technological parameter of the production and transportation chain for the delivery for bulk cargoes by exit routes. The operational work of railway transport is planned ensure compliance with the delivery interval for proposed for implementing the just-in-time requirements. For the further development high-tech production and transport system, significant investment are needed. Efficient use of investment will provide an integrated approach that will ensure the optimal sequence of development of elements of the production and transport